Welcome to class today, pre-cal students. Hope you guys are doing well. Hope you enjoyed your 3-day weekend. I know I did. And unfortunately, today is back to the grind. Let's quickly look at some announcements. Today's video is average long. It'll be average long to a little longer than usual. And you'll have 16 homework problems, so please be ready to handle the workload. You will have a test in 6 days. That's on a Monday at my house. You do not have to come to my house. That's your decision. I am not trying to get out of work. I'm trying to make this as easy as possible for you and your parents when it comes to transportation and also working in your own time frame on a daily basis. So that's up to you. Although I want you all to come and I'm here to help you, that's your decision. If you're doing super well on this and you're ready for the test and you're like, I really don't need to come to Mr. Earhart's house to take the test, then that's fine, whatever you choose. But we will have a test a week from this, or this coming Monday. I believe that would be the 9th, I believe. And so be ready for that. This Thursday, when the video is over, you'll be given a review sheet. And what that means is Friday's video, I will not teach anything new, but Friday's video will be me working out the review sheet for you. So we'll go over all that more as the week progresses. You owe me a quiz by today. Now all that I ask is communication. You don't have to bring it by the house. You're more than welcome to. You don't have to. Email me, yo, Mr. Earhart or Mr. Mike or Mike, whatever you want to call me. I'm done with my quiz. Let me know. If I don't hear from you, I contact your parents. I'm like, hey, your son did not turn in your quiz. Now, in fact, one example would be Matthew. I know, Matthew, you've been, I think, a soccer tournament or something, your mom told me, so I know that you might need a little more time, and that's fine. I just need communication from you or from your parents, okay? That should pretty much do it on the announcements. Let's get ready to roll. We have a lot to learn today. Hopefully, I will teach this well, and hopefully you will listen well. We're going to look today, we're starting chapter 5 now. We're starting our 3 chapters on trigonometry, chapters 5, 6, and 7. They're going to be challenging, like it should be, a good academic class where you learn. And so we're going to start those lessons today. Write this heading down while I'm talking, and by the way, the date today, if you'd like to keep track of that, and I encourage you to do that, today's the 3rd. 6 trigonometric functions, lesson 5.1, and I doubt if I'll use this word again the rest of the year. I'm usually going to say trig. It's a lot easier, and it's used normally in math classes. So 6 trigonometric or 6 trig functions, lesson 5.1, the date's 9/3/13. So we're going to be looking today at 6 trig functions. All right, now please take some really good notes. Once again, I go fast on purpose. You can always slow me down by pausing it, but you can't speed me up, so I'm going to go pretty fast. We'll be looking at 6 trig functions today called sine. You need to know the abbreviation for that. It looks like sin, but it's pronounced sine. So there's the abbreviation for sine. Cosine, the abbreviation for cosine is COS. Tangent, the abbreviation for tangent is TAN. Cosecant, the abbreviation for cosecant is CSC. Secant, the abbreviation for secant is SEC, and cotangent, the abbreviation for cotangent is COT. Now, for those that have had geometry, Matthew, I know you have not, and that's okay, you'll be fine, but those that have, you've probably been introduced to these 3, and maybe these 3, maybe not, okay? So those might be new to some of you. But we're going to look today at how to use these 6 trig functions, sine, cosine, tangent, cosecant, secant, and cotangent. Now, remember, I go fast on purpose, okay? Please don't let these scare you. They are nothing more than ratios / fractions. That's it. When I ask you to find the sine of some angle, like let's find the sine of 35 degrees. Don't write that down, just listen. Your answer is just going to be a ratio, a fraction, like some number over some number. Or it could be a decimal if you divided it out. But the point is don't let these words scare you. It's not that difficult, okay? You're going to have to think, but it's not super hard. When I ask you to find one of these functions, all that you are doing is using 2 sides of a, and I forgot a word here, please put this word in. In fact, you know what? I really like my videos to be ready for next year too if I teach this class, so I'm going to fix this right now. Thank you for your patience. I do appreciate that. should be right triangle. There we go. When I ask you to find one of these functions, all that you are doing is using two sides of a right triangle and making a ratio fraction. That's it. That's it. Now, which two sides of the triangle? Well, that's the catch, and I'm going to give you formulas here in a little bit. All right. These trig functions only work on right triangles. Please don't forget that. It's very, very, very important. Again, you take notes on what you think you need to take notes on when it comes to these sentences. Some of them you might feel a little, they're a little useless, and others you might like. So that just make a good, wise decision and be a hard worker, okay? These trig functions only work on right triangles. Don't forget that. Now, I really didn't want that to pop up yet. I wanted to show you something else first. So just ignore this for 1 second. Let me go like this, and that, and we'll get back to that in a second. All right, now, watch carefully. Let's look at the formulas, the ratio formulas, for each type of trig function. I mean, each trig function, sine, cosine, tangent, cosecant, secant, cotangent, has a formula. But before I give those formulas to you, I want to go over something you need to see. So somewhere in your notes, I want you to draw a right triangle. Any right triangle will do. Wow, that's a really bad right triangle, isn't it? You guys are seeing how poor my drawing skills are. I'm going to cheat. Here we go. All right, go ahead and draw a right triangle in your notes, if you would, please. Put a right angle symbol here. Matthew, even though you've not had geometry, you should know this. A right triangle is a triangle that has one angle that's 90 degrees. All right. Now, go ahead and draw your right triangle, and I want to show you something. We're going to call this angle here x, okay, just because I feel like it. Now, if I call this angle x, I want you to get used to 3 words. Listen to me. Opposite, hypotenuse, adjacent. Those 3 words. Opposite, adjacent, hypotenuse. Now, if I circled this angle in the triangle, then I would call this side over here my opposite side. Okay? See this right angle here? We should know by now a right angle always is across from the hypotenuse, so we know this side here is the hypotenuse. And the only side left then we would call the adjacent side. Wow, mister, I don't get that. We're going to go over it again, so just relax. Whatever angle I circle, in other words, whatever angle I'm dealing with, you always go straight across to the other side and call it the opposite side. You then go to the hypotenuse and call it the hypotenuse, and then the last side is called the adjacent side. Let's say that I called this angle y down here, and let's say that's the angle I was dealing with. Okay, go straight across. Okay, you don't have to do the sound effects if you don't want to, but let's go straight across, and we're going to call that our opposite side. And of course we know this is my right angle, so this doesn't change. This is your hypotenuse. And this is your adjacent side. So do you see how the adjacent side and the opposite side switched when I switched angles? When I was dealing with angle x up here, I called this my opposite and this my adjacent. Do you see that? But when I said I was dealing with angle y, then this side became my opposite and this side became my adjacent. So it's very, very important, students, that you know what angle we're talking about. And then when you know what angle we're talking about, you can label all 3 sides of your triangle. Okay, having said that, I now want us to go ahead and look at these trig functions. You really do need to see these. All right, so here we go. All right, go ahead and start off by writing down this first formula. When I ask you to find the sine of an angle, we'll call it x. The formula you use is opposite over hypotenuse. Opposite over hypotenuse, okay? When I ask you to find the cosine of an angle, the formula you use is adjacent over hypotenuse. Adjacent over hypotenuse. When I ask you to find the tangent of an angle, the formula you use is opposite over adjacent. Opposite over adjacent. I cannot stress to you how important it is that you memorize these. You must know those. Now let me give you a really cool way to remember this. You'll like this. S-O-H. So I'm going to write a word called so. C-A-H. I'm going to write a word like ka, short A sound, and then T-O-A, toa. There's a little thing that we use in geometry. We call it SOHCAHTOA. SOHCAHTOA. That's so easy. Long O, short A, long O, short A. SOHCAHTOA. SOHCAHTOA. That's easy. And do you see what it does for you? I'm going to draw arrows here, put dots. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. SOHCAHTOA. Well, Mr. Earhart, what about the other 3 trig functions? There's 6 of together. We'll get to that in a second, okay? But I wanted to show you a really neat way to remember those. All right, let's continue on. Cosecant of angle x is hypotenuse over opposite. Secant of angle x is hypotenuse over adjacent. Cotangent of x is adjacent over opposite. Sorry, hold on one second. All right. Cotangent of x, adjacent over opposite. Now, do you not see the pattern? This is opposite over hypotenuse. This one is hypotenuse over opposite. They're flipped. This one is adjacent over hypotenuse. This one's hypotenuse over adjacent. It's flipped. This one is opposite over adjacent. This one's adjacent over opposite. It's flipped. So if you can remember that sine and cosecant kind of go together, then if you know what sine is, you know cosecant is just flipped. If you can remember that cosine and secant kind of go together, then if you know what cosine is, you can flip it and you know what secant is. And if you can remember that cotangent and tangent kind of go together, then if you know what tangent is, and you do know what sine, cosine, and tangent is because you have this cool thing called SOHCAHTOA. And so if you know what tangent is, then you remember that cotangent is just flipped, or we use the proper math word, the inverse. So that's a pretty helpful way to remember all 6 trig formulas. You need to have these in the notes. You need to memorize them. You need to quote them before you go to bed every night. I'm just kidding with you, but make sure you know these, okay? That's really, really, really important. All right. Now what I want you to do, we're going to start working some problems now. So take a deep breath, say a word of prayer, and here we go. I want you to draw a right triangle in your notes, okay? And I'm just going to make up some sides here. They might not be correct. Oh, what's the word? Mathematically. We're just going to say we're going to throw a 10 here, I guess, and a 3 here, and an 11 here. Good enough for me. All right? Now, what I want us to do, we're going to call this angle X and this angle Y. By the way, I better get rid of X and Y, just so you know. Instead of using, go ahead and put X and Y, but I want you to be ready for something. Most pre-cal books, and this one is no different, they like to use Greek letters of the alphabet for angles instead of X and Y. They're going to see stuff like theta, beta. I don't even know. Some of these I don't know. I think this one's alpha. I could be wrong. Looks like a fish, doesn't it? That's a really bad drawing. Something like that. You're going to see other ones, okay? Don't let that freak you out. Instead of using the unknowns X and Y, you're going to see in your homework they use Greek letters. So what? What's the big deal? It's no big deal. So just understand that, and it's okay. All right, are you ready for our first trig moment? We are going to find the sine of X, the cosine of angle X, the tangent of angle X, the cosecant of angle X, the secant of angle X, and excuse me, the cotangent of angle X. We're going to go pretty fast, guys, because you have the formulas, don't you? So, you're going to have to pause the video if you get a little lost. Now, what angle am I dealing with? If you can't see that, you got to get glasses, okay? X. See all these X's? We're dealing with angle X. So if we're dealing with angle X, I'm going to come over and I'm going to circle angle X. Now remember what I taught you earlier. If you're dealing with angle X, then go straight across to this side, and we're going to call this side our what side? Opposite. Here's my right angle. Go straight across. This is going to be my hypotenuse. And this is my leftover side, so the third side left over without a name, we call that the adjacent side. Now watch how fast this is. The sine of X, look at your formulas in your notes right now as you're doing this video. You should have your formulas right beside you. If you'll look at your formulas, the sine of X is opposite over hypotenuse. Well, that would be 3 over 11, opposite over hypotenuse. Cosine is adjacent over hypotenuse. Well, that would be 10 over 11. Tangent of angle X is opposite over adjacent. That would be 3/10. Now, you can do cosecant 2 different ways. If you want to remember that sine and cosecant are inverses of each other, then if sine of angle x is 3/11, then the cosecant of angle x is 11/3. You just flip it. If you don't want to use that method, then use the formula. Look at your notes. The formula for cosecant should be hypotenuse over opposite, which would be 11/3. That's totally up to you. I don't care how you get this right, as long as you don't cheat, of course, but just make sure that you use one of those two methods. Okay, secant of x. Now, secant is the inverse of cosine, so 11/10, or you can remember that secant is hypotenuse over adjacent, which would be 11/10. Cotangent is the inverse of tangent, so if tangent is 3/10, then cotangent is 10/3, or you can remember that cotangent is adjacent over opposite, which would be 10/3. Cool beans, we did it. We just found the 6 trig functions of a given angle using a right triangle. I think, personally, that's really cool. Now I want you to try another one, all right? Because I know you're just loving this so much. Now, let's find, so somewhere in your notes, write down the sine of y, the cosine of y, the tangent of y, the cosecant of y, the secant of y, and the cotangent of y. And let's see if we can't find the trig functions of the angle y. Now I'm going to change colors. I'm going to go to blue. Now we're dealing with angle y, so some of the sides are going to change. I'm going to circle angle y, and now I'm going to go straight across. So now this side over here is my opposite side. Then next I go to my right angle and I go straight across. It's still my hypotenuse. And the only side left that I haven't named yet with this new angle would be this side, so I'm going to call that my adjacent. Do you see how important it is to get every single side labeled correctly? Let me grab a drink of water here. It's really important that each side is labeled correctly, because once you've done that, everything else kind of fits right into place pretty quickly and pretty easily. Okay, the sine of y is opposite over hypotenuse. Well, that would be 10/11. Cosine of y is adjacent over hypotenuse. That would be 3/11. The tangent of y would be opposite over adjacent, so that would be 10/3. The cosecant of y is the inverse of sine, so if sine is 10/11, then the cosecant would be 11/10. The secant of angle y is the inverse of the cosine of y. If the cosine of y is 3/11, then the secant of y would be 11/3. Cotangent of y is the inverse of tangent. If tangent is 10/3, then cotangent would be 3/10. And I hope that we got all these correct. I hope I'm not making any mistakes anywhere. But that is how you find the trig functions of a given angle in a right triangle. Now, on your own, I want you to draw another right triangle, and I want you to label this 6, 8, and 10. Put a right angle symbol right here. And on your own, we're going to call this x and y. And on your own, I want you to find the sine of x, the cosine of x, the tangent of x, the cosecant of x, the secant of x, and the cotangent of x. Now, let me give you some instructions. I want to remind you that whenever you give an answer, a ratio, a fraction, you should always reduce it. So your answers are all going to need to be reduced. Like if you put 6/8 for an answer, then reduce that to 3/4, okay? But I want you to go ahead and do these 6 problems on your own. And you're going to pause the video and do that, and then when you're done, start the video and see if you got these 6 problems right. So go ahead and do that now on your own. Okay, students, I hope you did well on this activity. First of all, notice I'm dealing with angle x. That's the first thing you should have noticed. If you missed that part, if you missed any of this, please correct it in your notes so your notes are accurate. We're dealing with angle x, so I come over and circle angle x. Then I go straight across. So this 8 right here would be my opposite side. Then I go to my right angle and go straight across. That would be my hypotenuse side. And the only side left, which is 6, in this case, is my adjacent side. So I'm going to go pretty quickly. The sine of x is opposite over hypotenuse. That would be 8/10. You must reduce that to 4/5. The cosine of x would be adjacent over hypotenuse, which is 6/10. you must reduce that to 3/5. The tangent of x is opposite over adjacent, which would be 8/6. Reduce that, and that would be 4/3. I should cross these off. These are not, they're the correct answer, but they're not simplified. Now the cosecant is always the inverse of sine. If the sine of x is 4/5, then the cosine of x would be 5/4. Now don't get confused about which trig functions go with which ones. Sine goes with cosecant, cosine goes with secant, tangent goes with cotangent. Please don't forget that. Okay, secant of x. Secant is the inverse of cosine, so if cosine is 3/5, then secant would be 5/3. Cotangent is the inverse of tangent. If tangent is 4/3, then the cotangent would be 3/4. I hope you got all of these right. If you did not, please find your mistakes, back up the video, do it again, whatever you need to do to make sure that you're getting these correct. All right, let's continue on. Now, I'd like you to write this problem in your notes. Please copy this problem in your notes. Given that sine of x equals 4/5 and cosine of x equals 3/5 and tangent of x equals 4/3, find cosecant, secant, and cotangent of x. Now, this is pretty simple. Just stop and think for a second. We're trying to find the, write this down please, the cosecant of x. And I know some of you are still copying the problem down. That's fine. That's where you pause the video and copy the problem down, then move on, okay? You can always slow me down, but you can't speed me up. Cosecant of x, secant of x, and cotangent of x. That's what the problem has asked us to find. Is that correct? We're trying to find the secant, the cosecant, secant, and cotangent of x. Now, you don't need, Mr. Earhart, where's the right triangle? I got to label my sides, my opposite, my adjacent, my hypotenuse. No, you don't. Not at all. If you simply remember that cosecant is always the inverse of sine, then if sine of x is 4/5, then the cosecant of x is 5/4. See, if you know these shortcuts, you don't even need to draw the right triangle sometimes. If you remember that the secant of x is the inverse of the cosine of x, well, if the cosine of x is 3/5, then the secant of x is 5/3. And if you remember that the cotangent of x is the inverse of the tangent of x, well, the tangent of x is 4/3, so the cotangent of x must be 3/4. Not a difficult problem. If you're listening to what I'm teaching you and learning it, it's not that bad. Okay, let's continue on. Now this is bad. Okay, this is going to be a difficult problem, and it's the last one before I give you your dreaded homework. Okay, so please, please listen, work well, and take some good notes. Here we go. Copy this problem in your notes. If the sine of b is 6/7 and b is an acute angle. Now really don't worry about that phrase. You're going to find out later on why they put that in there. Not today, but another day. So don't worry about that phrase there. If sine b equals 6/7 and b is an acute angle, then find the other 5 trig function values of b. Now let me walk you through this step by step. They've given you only one trig function. The sine of b is 6/7. So here's what I want you to do. I want you to draw a right triangle. We can all do that. Okay? Go ahead and draw a right triangle. Now, I'm going to ask you questions you can answer out loud or just kind of listen for my response. What angle are we dealing with? Well, it looks like sine of what angle? B, sine of B. So we're dealing with angle B. So you're going to write angle B here, or you're going to write angle B here. Are you listening, students? It doesn't matter. I mean, it does matter if you're listening. It does not matter where you write B, okay? I don't care where you put the letter B, as long as you don't put it here with the right angle, because we know that's 90 degrees, okay? So, pick a place and put B. I'm going to do it up here. I think we should all do it the same place, so it just is easier that way. So I'm going to put B there. Everybody good with that? All right. Now, let's continue on. If this is B, what would I call this side over here? Well, hopefully you said opposite. If you did, you're right. Opposite. Here's my right angle, so I know this is my hypotenuse. The only side left is this side. I'm going to call it the adjacent side. Mr. Earhart, if I would have put B down here, would have I still gotten the right answer? Yes, you would have. Totally. Trust me, I know my math. Yes, you would have. Now, watch this carefully. The sine of angle B is 6/7. Now watch what I do. Watch carefully. The sine of b equals what? 6/7. Let's go way back to our formulas. Booyah. Look at this. What is the sine of x, or any angle? What's the sine of any angle? Opposite over hypotenuse. Opposite over hypotenuse, right? So with that in mind, if I tell you the sine of b is 6/7, then you know 6 is the what side? Doesn't that make sense? Think about it. Opposite over, so 6 has to be your what side? Opposite. And 7 has to be your what side? Hypotenuse. That should make total sense. I mean, look, guys, we know the sine of any angle is opposite over hypotenuse, and we know the actual answer to the sine of b is 6/7. So 6 must be your opposite side, and 7 must be your hypotenuse. So I'm going to come down here, and for the opposite side, I'm going to label this a 6. And for the hypotenuse, I'm going to label this a 7. Now, I told you this is a hard problem, all right? Now, hopefully in algebra class, I'm going to switch screens here for a second. Hopefully in algebra, I know, Matthew, again, I know you've not had geometry, and that's okay. But hopefully in your algebra and pre-algebra, you should have somewhere along the way, all of you should have studied that wonderful man called Pythagorean who came up with Pythagoras Theorem, okay? And Pythagoras Theorem is a squared plus b squared equals c squared, okay? Now these two here, take some really good notes if you need to, are the legs, and this c right here is your hypotenuse. Got it? These two are your legs, and this c stands for the hypotenuse. Now, the reason I'm telling you this is anytime in a right triangle you know two sides, you can find the third side so easily by using Pythagoras Theorem. Okay? Now, A is one of my legs. So I'm going to go ahead and put 6 because 6 is one of my legs. This is your hypotenuse right here, students. This is your hypotenuse, okay? If that's your hypotenuse, we call the other two sides the legs. So if you didn't know that, now you know it. The other two sides are called legs, and this is called the hypotenuse. So for A squared, one of my legs is 6. I'm going to put 6 squared. Now my other leg is this side right here. Do you know the length of that side? No, you do not. So I'm going to put b squared. Do you know your hypotenuse? Yes, you do. It's a 7. So I'm going to put 7 squared. Now I'm going to solve for b, and once I solve for b, I'll know the length of this side right here. And then I'll know all three sides of the triangle. And hey, I just had a thought. I don't have many of those. Once you know all three sides of your triangle, then you can find all the trig functions. So this isn't too bad. So 6 times 6 is 36 plus b squared equals 49. Now let's subtract 36 from both sides. So b squared equals, bring the 36 over, make it a negative 36, 13. Now take the square root of both sides. Well, the square root of b squared and the square root of 13 would be, the square root of b squared is b, and I do not want a decimal for this. No decimal. Square root of 13. So now you found the length of the adjacent side. It's square root of 13. Now you know all three sides. Now if you got to back this up and watch it again 2 or 3 times, do whatever it takes, okay? That's what this math class is all about. Now, I'm going to come back here, and I'm going to put square root of 13. Now we can finish the problem. This is so cool. Find the other trig function values. We already know what sine is. They gave us sine already, so I'm going to put sine of b equals 6/7. And then cosine of b equals tangent of b equals cosecant of b equals secant of b equals and cotangent of b. We're going to find these other 5. This shouldn't be too hard. Now, I'm almost done, guys. Just 45 more minutes. I'm kidding. Almost done. Cosine of b. Cosine is adjacent over hypotenuse. So that would be square root of 13 over 7. Tangent of b. Opposite over adjacent. Adjacent. 6 over the square root of 13. Cosecant of b. Well, that's the inverse of this right here. So the inverse of 6/7 would be 7/6. The secant of b. Well, secant is the inverse of cosine. Cosine is square root of 13 over 7, so this would be 7 over square root of 13. Cotangent is the inverse of tangent. If tangent is 6 over square root of 13, then cotangent would be square root of 13 over 6. Man, we are moving right along. We're doing great. Now, I got to be honest with you. You're not going to like this. We're done. We solved the problem. Look, we found the other 5 trig functions. Right here. There's the other 5. We did it. But there's something you need to know you're not going to like, okay? So I'm going to warn you about that. So please watch carefully. Okay, now in the back of your book, and by the way, don't criticize the book, okay? All pre-cal books are like this. But in the back of the book, there are some answers they're not going to accept. And guess what? Your kind, loving teacher is the same way. I'm not going to accept some answers. You know why? Not because I'm mean, because I want you ready for college. I want you ready for the ACT or the SAT test, okay? So, the back of the book and on my tests and quizzes, I am not going to allow you to have answers that have radicals in the denominator. A radical is a square root or a cubed root or a fourth root or a fifth root. You get the idea. I do not want any of those in the denominator of a final answer. So this one's good, this one's good, this one is not. Look, there's a radical in the denominator, so we're going to have to simplify, and I will teach you how to do that in a second. This one's good, this one's good. I don't care if you have a radical in the numerator, that's totally fine. You cannot have a radical in the denominator. So I'm going to teach you quickly how to take care of this. If you have 6 over, sorry about that, if you have 6 over the square root of 13, whatever you want to get rid of the square root of 13, what you do is you multiply it. It's so easy. You simply multiply that times the top and the bottom. That's all you do. So, that easy, guys, okay? So, I'm trying to get rid of the square root of 13, so I multiply the top and the bottom by the square root of 13. So 6 times the square root of 13 is just like this. You leave it just like that. Just put them side by side. It's that easy. And now, come on, guys. Square root of 13 times square root of 13. Type that into your calculator. You should know where the square root button is. If not, I can show you. But square root of 13 times square root of 13 will give you just simply 13. Can I show you a shortcut? Anytime you take a square root times a square root and it's the exact same square root, you get out that number. In other words, the square root of 1,500 times the square root of 1,500, the answer is just 1,500. Okay, that's a shortcut and it works every time. And very quickly, I don't want to put you to sleep, I'm going to show you why real quick. The square root of 2 times the square root of 2 would be what? Using the shortcut I just taught you, it would be 2. Let me show you why. The square root of 2 times the square root of 2 is the square root of 4. And what is the square root of 4? It's 2. That's why that works, okay? So the square root of 13 times the square root of 13 is just 13, and that is how you have to write your answer. So this is the right answer, but you'll still lose points because it's not written in the right form. This is how you've got to write your answer. So you can try this one on your own, or you can watch me. This one here is unacceptable because we have a radical in the denominator. So I have 7 over the square root of 13. So I'm going to multiply the top and the bottom by square root of 13. Obviously, 7 times the square root of 13 is 7 square root of 13. And square root of 13 times square root of 13 is just 13. So that's the answer you want instead of this answer. So again, I do not want radicals in the denominator. Now, love y'all, care about you. I hope you know that by now. Do your homework. Please do your homework. If you are not doing your homework and checking your answers, first of all, if your parents are paying for the class, you're kind of really you're wasting their money in a way. You need to be respectful of the fact that they're spending money for a class. Number 2, your education is very important. Mr. Earhart, I'm going to major in whatever you like, automotive. I'm gonna major on English or something non-math related. I understand that, but there are still basic math classes that are required to take in college, just basic college algebra, for example. and you need to be well-founded. Plus, you're going to take ACTs and SAT tests. You need to know your math well. Please do your homework. Please check your answers in the back of the book. If there's even ones, check those in the video, and make sure you find your mistakes if you miss any. Have a great day, and I hope you do well, and we'll talk to you on Wednesday.